So this is for the density part of the final lab exam, and I have this piece of halide here, which by the way is broken off parts of it, and I'll talk about it in just a moment. So all I have to do is put it on the scale. The scale reads 18.1 grams, and now I'm going to measure the dimension. This is almost a cuboid, so the shortest dimension that, okay, actually not, it's the width that I measure, and that one is 2.1 centimeters. Now the shortest dimension, so it's kind of like the height of it, that one is 1.5 centimeters. And now comes the tricky part. The length of it is kind of half broken off, so I'm taking an average here, and I want to say I'm coming up with 2.3 centimeters, and that's actually it. That's all you need for the numbers, and figure out the density and compare it to the published density of halide, which is rock salt, and compare. Alright, pendulum obviously, and I'm going to start the stopwatch right now. Okay, 1, 2, 3, 4, 5, and of course you can count too and use your own stopwatch. 6, 7, 8, 9, 10. I counted the bricks, 11. I came up with, that's 12. I came up with 33 bricks. 13, 13, 14, 15. Each brick is 10.1 centimeters. 16. So a total length of 17. A total length of 18. 19. 20. Okay, total length of 333 centimeters, and I stopped 72.67 seconds. And this was quite a chore to set this up, as I wanted to get a really long pendulum, and then I really didn't have much to rig it up with, or I was too lazy to return to the lab. Anyway, up there it is. I hope we can see that. It's actually really rickety, which makes probably not for a good length measurement. And then I had to push it off from the wall because it was so close and so on. Anyway, so these are the measurements for the pendulum. By the way, this is the setup of the pendulum from above. The way down there it is. So I put it on this rod here, on this aluminum rod, which I then there really strangely, and then I had to have a counterweight here because otherwise that lead ball down there would have just put too much torque in it and the whole thing would have fallen apart. I'm actually surprised it's still holding here. So that piece of iron weight, I mean, I could use this here too for center of mass, right? But I already did the Panther and the R2D2 for that one. Alright, so this is projectile motion. I'm going to shoot it from a given height from over here, which will be 90 centimeters, and then I already put a couple of meter sticks down there, kind of. I did measure their distance as well. So I'm going to shoot this horizontally, have this little Nerf gun, and let's see where it ends up. Alright, okay, I have to replace it later when I'm done. And then measure the distance. Whoa, okay. It's gonna be quite a spread. Okay. jumped quite a bit, and I don't remember exactly where they jumped to, so I'm just gonna do this and shoot a couple more, just for good measure. Alright, that's way long there. That's way long. Okay, let's just use these four here for some good measurements. Okay, let's see. This one is 330 centimeters. This one is 480 centimeters. This one is 570 and 580 centimeters. So as I said, quite a spread. All right, so this is for the center of mass part, and I have hanging here R2-D2 and a Black Panther, and I'm measuring the distance, the distances, the lever arms. So from the pivot point, which by definition is 0, I'm going to measure to the right to the Panther, and I'm getting a distance of 21.3 centimeters. So positive 21.3 centimeters because I'm measuring to the right, and for R2-D2 that will be a negative. And I'm measuring 28.5 centimeters, and then the middle of the rod is over here and it's to the left, so it's also negative. So this one comes out to 4.3 centimeters. And now I need the masses. I don't need any other measurements, as you know, because the length of the string is irrelevant, and this piece over here is also irrelevant. So here is the mass of the Panther. I have to make sure that it rests nicely. Yep, 40.0 grams. R2-D2, 29.0 grams. And the rod is going to be a little tricky. No, actually it's okay. 6.1 grams. Alright, and that's actually all the data you need for that one. Alright, this is the hydrostatic pressure. So I'm gonna remove the lid here, and as you can see it comes out. I measured the height before here. This is 15 centimeters, and the water level right now is way up here. I want to measure it here where this one is 14 centimeters. So remember that this Y here is 15, and the height for the hydrostatic pressure is from here to there to the hole 14. Okay, now I'm going to wait here until I reach the bottom part of it, and I'm going to read off, and I'm reading off right now 20 centimeters. So those are really the only measurements we need. So this is about the volumetric expansion of mercury. Mercury is a liquid in this thermometer here, and it only has a volumetric expansion. Of course, you can say that because the cross-section here is so thin, it's virtually linear actually, but in any case, okay. So I put it here in room temperature water, 25 degrees Celsius. Turns out actually this room is rather warm. Okay, so this is 25 degrees Celsius, and there it is. And then I'm going to put it into hot water that I just filled in here from the heater right next to me on my right, and I don't think you can see this in the video. In any case, the temperature is rising quite a bit. And I'm gonna stop it here at 85 degrees Celsius is the water. And now I'm gonna measure the difference here in length. Remember that aluminum actually is volumetric expansion, but of course the thermometer has a length to it. So between 25 and 85, I measured 10.7 centimeters by how much it expanded, times of course the cross section, and from that you have to figure out what is the volumetric expansion of mercury. By the way, again, I don't think you can see this one here, these numbers on here. I had this thermometer in possession for the last 25 years, and this is the way it reads: 20, 30, 40, 50, 60, 70, 80, everything okay, including my 85 actually, and then it says 100. 110. So the manufacturer actually left out the 90. I still can't figure out how that happened, how they could print all these numbers on there, in one big batch, leave out the 90. So there must be a batch of thermometers that came out with that. But I kept it all this time here to show, hey, if you have faulty equipment, it gives you systematic errors. In this case, actually, my thermometer worked for this one here because I was only measuring to 85. All right, or if I had measured beyond it, I would just simply subtract 10, right? Okay, that's actually it.